Good morning to everyone. In this session, we are going to see composite material. What is composite material? A composite material made from two or more constituent materials with significantly different physical or chemical properties that, when combined, produce a material with characteristics different from the individual component. The individual component remains separate and distinct within the finished structure. The new material may be preferred for many reasons. A common example include material which are stronger, lighter, or less expensive when compared to traditional material. Important of composite material. Composite can be very strong and stiff, yet very light in weight. So ratio of strength to weight and stiffness to weight are several times greater than steel or aluminum. Factive properties are generally better than for common engineering metal. Toughness is often greater too. Composite can be designed that do not corrode like steel. Possible to achieve combination of properties not attainable with metal, ceramic, or polymers. These are the importance of composite material. Next, properties of composite material. In selecting a composite material, an optimum combination of properties is usually sought rather than one particular proper property. And fuselage and wing of an aircraft must be lightweight and be strong, stiff and tough. Several fiber reinforced polymer possess like this combination of properties. Example, the natural rubber alone in relatively weak, adding significant amount of carbon black to another increase its strength dramatically. One possible classification of composite material. Traditionally, composites. Composite material that occur in natural or have been produced by civilization for many years. Example, wood, concrete, asbestos. The synthetic composite means the modern material system normally associated with the manufacturing industries in which the components are first produced separately and then combined in a controlled way to achieve the desired structure, properties, and part geometry. Component in a composite material. Nearly all the composite material consists of two phases, primary phase and secondary phase. Primary phase is the form of matrix within which the secondary phase is embedded. Okay, the secondary phases is the embedded phase, sometimes referred to as the reinforcing agent, because it usually severals to strengthen the composite. The reinforcement phase may be in the form of fiber, particle, or various other geometries. So this is a matrix is a continuous one. The dispersed is a discontinuous and surrounded by matrix. You can see this figure. Then function of matrix. So binds fiber, act as medium, protect fiber, prevent propagation of cracks. These are the functions of matrix. Essentials of matrix phase. It should be ductile. Bonding strength should be high. Corrosion resistance. Then classification of dispersed phases. The dispersed phase can be fiber, particle, etc. Fiber, that means glass fiber, carbon fiber, and aramid fibers. Okay, then particles means the metallic or non-metallic. Flakes means 2D particles. Viscous, that is a thin crystals with the high empathic ratio. Example, graphite, silicon carbide. The function of matrix material is a primary phase. It means the provide the bulk form of the part or product made of the composite material. Hold the embedded phase in phase, usually enclosing and often concealing it. Okay. Then when a load is applied, the matrix shares the load with the secondary phase. In some case, deforming so that the stress is essential bond by the reinforcing agent. The reinforcement phase, that is a secondary phase. The function is to reinforce the primary phase. The embedded phase is most commonly one of the following phases: fiber, particle, and flex. In addition, the secondary phases can take the form of infiltration phases. in a skeleton or porous material. Example, a powder metrology pot infiltrated with polymer. This is a composite survey. That is a composite is a mainly classify the particle reinforcement and fiber reinforced and structural. The particle reinforced include the large particle and dispersed strengthening. And fiber includes means continuous and discontinuous. And structural means it classify into lamination and sandwich panels. Okay, so discontinuous means allied and randomly oriented. Then classification of composite material by matrix. It's a ceramic matrix composite in which the silicon carbide, then silicon carbide. It's the same material, both matrix and filler, but filler different from such a viscous and soaped fibers or strands to achieve the preferred properties. The hybrid composite means in incorporation of two or more fibers within a single matrix result in formation of hybrid composites. These are the different hybrid configurations. Then hybrid composites or composite consist of two constituents at the nanometer or molecular level. The commonly one of these components is inorganic and the other one is organic natural. That's the different form of traditional composites where the constituents are at the macroscope, that is micrometer to millimeter level. Mixing at the micrometer scale leads to more homogeneous material that either show characteristics in between two original phases or even new properties. So advantages of hybrid material over traditional material means in inorganic clusters are nanoparticle with the special optical, electronic or magnetic properties can be incorporated with organic properties material matrix. Contrary to pure solid state inorganic material that often require a high temperature treatment for their processing, hybrid material so a more polymer like handling either because of their large organic content or because of the formation of cross-linked inorganic network from small molecular and precursors just like polymerization reactions. So another classification of composite material. First one, metal matrix composite, that is MMC, ceramics material composite, and polymer matrix composite. Metal matrix composite means the mixture of ceramics and metals such as cemented, carbide, and other ceramics. Ceramics matrix composite means the aluminum oxide and silicon carbide embedded with the fibers to improve the matrix and especially in high temperature application. Then polymer matrix is that thermosetting resins are widely used in the polymer matrix composites. Example, epoxy and polyester with the fiber ribbons, reinforcement and phenolics with the powder. So fiber means the filament of reinforcement material, usually circular in cross section, and diameter ranges from 0.0025 mm to 0.13. The filament provide the greater opportunities for strength engagement of composite. The filament form of most materials significantly stronger than the bulk form. Then fiber orientation, the three cases. So one is one-dimensional reinforcement in which the maximum strength and stiffness are obtained in the direction of the fiber. Then planar reinforcement in some cases in the form of two dimensions woven fabrics. Then random or three dimensions in which the composite material tend to possess the isentropic properties. Then material for fiber. So fiber materials in fiber reinforced composite, glass and carbon, boron, polymer, ceramics, metals. These are the most commercially used in the fiber composite. Then metal matrix composites, there is a particles of ceramics. Then fiber of various materials. Okay, fibers of various materials include the ceramics, carbon, and boron. Then metal matrix composite, it includes the aluminum, manganese, ferrous, and copper, nickel. So this is the different metals or another materials such as ceramics or organic components. Example, aluminum, silicon carbide, aluminum oxide. These are the high strength and high stiffness, dimension stability, high temperature and toughness. Then composites, the metal matrix composites are mainly of disposed reinforcement material into material matrix. The reinforcement surface can be coated to prevent a chemical reaction with the matrix. For example, carbon fiber are commonly used in the aluminum matrix synthetics composite showing low density and high strength. Then fiber reinforcement polymers. The fiber reinforcement polymer consists of a polymer matrix embedded with a high strength fiber. Usually, thermosetting plastics such as unsaturated polyester or epoxy can also be thermoplastics such as nylon and polycarbonate and polystyrene and polyvinyl chloride. So fiber reinforcement is widely used in the rubber products such as tire and conveyor belt. And these are the fiber reinforcement polymer. The reinforcing the fiber can be made of metal, ceramics, glasses, or polymers that have been turned into graphite and known as carbon fiber. Fiber increasing the modulus of the matrix material. The strong covalent bond along the fiber strength gives them the very high modulus in this direction, because to break or extend the fiber, the bond must also be broken or removed. Fibers are difficult to process into composite, which makes the fiber reinforced composite relatively expensive. The example for the fiber reinforcement polymer is the race car and automobile parts are making these reinforcement fiber reinforcement polymers. These are the different fiber composite manufacture often rotate the layers of fiber to avoid the direction variation in the modulation. First figure shows the continuous and aligned fiber. Second is discontinuous and aligned fibers, discontinuous and randomly oriented fibers. Then fiber reinforcement composite is a composite building material that consists of three components. The fiber as a discontinuous or dispersed phase, and the matrix or the continuous phase, and the fine interface region also known as the interface. This is a type of advanced composite group. And the fiber reinforceable polymer properties: high strength to weight and modulus to weight ratio, low specific gravity, low factive strength, low corrosive resistance, and low thermal expansive, significant and anti-stress in properties. Then applications of fiber reinforcement polymer: aerospace, automotive, and sports and recreation areas we are using these materials. Then advantages of composite: design flexibility. So we can, as per our requirement, we can making the product. So then low cost per cubic inch and low material cost, improved productivity. These are the advantages of composite. Then disadvantages and limitation of composite material: properties of many important composite and its product, and the properties different depend on the direction in which they are measured. This may be advantage or disadvantage. Many of the polymer based composites are subject to attack by chemical or solvent. Just the polymers themselves are susceptible to attack. The composite materials are generally expensive. Manufacturing material for shaping composite materials are often slow and costly. The application of composites: the aerospace and architecture, automotive, energy production, infrastructure, marine, pipe and tank, sports and transportations. These areas we are using the composite materials. Thank you.